In 1962 India, the Government of India set up the Indian National Committee for Space Research, which is also known as INCOSPER, was envisioned by Dr. Vikrama Sarabhai. Then ISRO was formed on August 15, 1969 and superseded INCOSPER with an expanded role to harness space technology. Now let us all know about ISRO. The Indian Space Research Organization, commonly referred to as ISRO, is the National Space Agency of India. It operates as the primary research and development arm of the Department of Space. Now let us all know the objectives of ISRO and its benefits to educational system. The prime objective of ISRO or DOS is the development and application of space technology for various national needs. ISRO has developed satellite launch vehicles like polar satellite launch vehicles and geosynchronous satellite launch vehicles to place the satellites in the required orbits. Alongside its technological advancement, ISRO contributes to science and science education in the country. Various dedicated research centers and autonomous institutions for remote sensing, astronomy and astrophysics, atmospheric sciences were formed. ISRO has its headquarters in Bengaluru. Its activities are spread across various centers and units. Launch vehicles are built at Vikram Sarabhai Space Center located at Thiruvananthapuram. Satellites are designed and developed at U.R. Rao Satellite Center at Bengaluru. Integration and launching of satellites and launch vehicles are carried out from Satish Dhawan Space Center located at Sriharikota. Now let us know the missions done by ISRO. Department of Space is Government of India department mandated with the execution of Indian Space Program. The Department of Space has evolved the following programs with the objective of promoting and developing application of space science and space technology. And the missions were: firstly, launch vehicle program having indigenous capability for launching satellites. Secondly, INSAT program for telecommunications, broadcasting, meteorology, development of education. Thirdly, remote sensing program for application of satellite imagery for various developmental purposes. ISRO discussed to research on the moon, and this project was split into several phases. Finally, ISRO's project to research on the moon was successfully planned and it was named as Chandrayaan. Chandrayaan-1, India's first mission to moon, was launched successfully on October 22, 2008 from SDSC SHAR Sriharikota. The spacecraft was orbiting around the moon at a height of 100 km from the lunar surface for chemical, mineralogical and photogeologic mapping of the moon. The spacecraft carried 11 scientific instruments built in India, USA, UK, Germany, Sweden and Bulgaria. During the tenure of Prime Minister Manmohan Singh, the Chandrayaan project got a boost and finally Chandrayaan-1 was launched on 22nd October 2008 at 12:52 Universal Time, which is in Indian time 6:22 AM from Satish Dhawan Space Center using the ISRO's 146 feet tall 4-stage PSLV C-11 launch vehicle. Chandrayaan-1 was sent to the moon in a series of orbit increasing maneuvers around the Earth over a period of 21 days as opposed to launching craft on a direct trajectory to the moon. The apogee was increased with a series of 5 orbit burns conducted over a period of 13 days after launch. For the duration of the mission, ISRO's telemetry, tracking and command network at Peenya in Bangalore tracked and controlled Chandrayaan-1. Scientists from India, Europe and the US conducted a high-level review of Chandrayaan-1 on 29 January 2009 after the spacecraft completed its first 100 days in space. After the successful completion of all the major mission objectives, the orbit has been raised to 200 km during May 2009. The satellite made more than 3,400 orbits around the moon and the mission was concluded when the communication with the spacecraft was lost on August 29, 2009. Now let us see the budget, the results of Chandrayaan-1 and Chandrayaan-2. India's third lunar mission, which is Chandrayaan-3, has been allocated a budget of Rs 615 crore according to WION. In comparison, the Chandrayaan-2 mission cost Rs 978 crore according to Times Now, while the budget for Chandrayaan-1 was Rs 386 crore according to ISRO. The mission was a significant success for the ISRO as it discovered water on the moon. Chandrayaan 2, on the other hand, was launched on July 22, 2019. However, after 48 days, the Vikram lander separated from the orbiter before it crashed on the moon's surface. After the success of Chandrayaan 1, ISRO planned the Phase 2, which is the Chandrayaan 2. Chandrayaan 2 mission is a highly complex mission which represents a significant technological leap compared to the previous missions of ISRO. It comprised an orbiter, lander and rover to explore the unexplored south pole of the moon. The mission is designed to expand the lunar scientific knowledge through detailed study of topography, seismography, mineral identification and distribution, surface chemical composition, thermophysical characteristics of topsoil and composition of the tenuous lunar atmosphere. On August 20, 2019, Chandrayaan 2 was successfully inserted into lunar orbit while orbiting the moon in a 100-kilometer lunar polar orbit. On September 2, 2019, Vikram lander was separated from the orbiter in preparation for landing, so as to change its orbit and begin circling the moon in a 100-kilometer into 35-kilometer orbit. Vikram lander descent was as planned and normal performance was observed up to an altitude of 2.1 km. The orbiter camera is the highest resolution camera in any lunar mission so far and will provide high resolution images which will be immensely useful to the global scientific community. The precise launch and mission management has ensured a long life of almost 7 years instead of the planned 1 year. Subsequently, communication from lander to the ground stations was lost.
Vikram lander descent was as planned and normal performance was observed up to an altitude of 2.1 km. Subsequently, the communications from the lander to ground station was lost. The data is being analyzed.
Both ISRO and NASA attempted to communicate with the lander for about 2 weeks before the lunar night set in, while NASA's LRO flew over on 17 September 2019 and acquired some images of the intended landing zone. However, the region was near dusk, causing poor lighting for optical imaging. On 16 November 2019, the Failure Analysis Committee released its report to the Space Commission, concluding that the crash was caused by a software glitch. Sadly, Chandrayaan 2 was declared as a failure. Now we are going to see the success story of Chandrayaan. The world has its eyes set on India on Wednesday, August 23, as the third lunar mission Chandrayaan 3 is set to attempt soft landing on the moon's uncharted south pole. The big moment not just for Indian Space Research Organization but for the whole world will be at 6:05 p.m. India's third lunar mission Chandrayaan 3 comes around 4 years after Chandrayaan 2, aimed at demonstrating end-to-end capability in safe landing and roving onto the lunar surface. It consists of lander and rover configuration. India is using rockets much less powerful than those the United States used back then, meaning the probe must orbit Earth several times to gain speed before embarking on its month-long lunar trajectory. The spacecraft's lander, Vikram, which means Velar in Sanskrit, detached from its propulsion module last week and has been sending back images of the moon's surface since entering lunar orbit on August 5. A day ahead of the landing, the ISRO said on social media the landing was proceeding on schedule and that its mission control complex was buzzed with energy and excitement. And at last, Chandrayaan 3 was launched aboard an LVM-3M4 rocket on 14 July 2023 at 9:05 Universal Time from Satish Dhawan Space Center, second launch pad in Sriharikota, Andhra Pradesh, India. After a series of maneuvers that placed Chandrayaan 3 in a trans-lunar injection orbit, ISRO performed a Lunar Orbit Insertion (LOI) on 5th August, successfully placing the Chandrayaan 3 spacecraft into an orbit around the moon. The LOI operation was carried out from the ISRO Telemetry Tracking and Command Network located in Bengaluru. On 17th August, the Vikram lander separated from the propulsion module to begin the last phase of the mission. The main mission objectives of Chandrayaan 3 are to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon, and finally to conduct in-sight scientific experiments. Chandrayaan 3 is a follow-on mission to Chandrayaan 2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. The propulsion model will carry the lander and rover configuration till 100 km lunar orbit. The propulsion module has spectropolarimetry of habitable planet Earth shape payload to study the spectral and polarimetric measurements of Earth from the lunar orbit. Everyone thinking that this achievement is the biggest achievement ever done by ISRO, but the real achievement is yet to come, which is the Aditya L1, which is yet to be launched in Sriharikota. And its mission is to research on Sun, and hope this one succeeds too. And finally, Jai Hind.